All right. So what I would like to do here to start off with is to just get ourselves a little bit of review to be safe. So I like to start with really tough questions so that you get your brain going. I do expect you to be able to add and subtract whole numbers, folks. I also expect you to be able to multiply them. One of the things I like to point out is some of the other notation for multiplication in case you haven't seen it before. So the X is the usual method. Sometimes you will see a star. Sometimes you will see a dot. All of those represent multiplication. In addition, there is something called implicit multiplication, where if you have a number outside of parentheses and there's nothing between the number and the parentheses, that means multiply. Okay? All of these things are the same. Please treat them as such. And of course, 4 times 2 is 8. Okay? So mostly this is just making sure you see the notation. In addition, you can divide. Please note that the backslash is often considered division. And fractions, folks. There's no such thing as a fraction. A fraction is just division. That's all there is to it. So everybody who says, I hate fractions, think to yourself, there's no such thing. It's just division. It's just a number, okay? It just might be a number that you have to do some division to figure out, all right? And the nice part about it is that these things, again, all work the same way. 4 divided by 2 is 2, all right? Now, what you maybe need a little bit of a refresher on, just to be safe, is dealing with things where we get a little bit out of the ordinary. 4 minus 1 we learned in, 2nd, 3rd grade. 1 minus 4 we tend not to learn until 6th or 7th grade, because now we can start getting into negative numbers, all right? When you're dealing with subtraction, you always will subtract the numbers the way you think they should be subtracted, okay? You're going to do 4 minus 1 in your head and say 3. But you have to be intelligent enough to think, should it be negative or not? Look to see which number is bigger. Whichever number is bigger, that's the sign that wins, okay? So what I like to tell students a lot of times is that what 1 minus 4 really is 1 plus negative 4, okay? And you guys have to be able to deal with negative numbers, because how much debt does our country have? $17 trillion. That's a really big negative number. Okay? And business deals with debt. And debt, folks, is a negative. Okay? So you have to be able to work with them at least a little bit. All right? So be able to add them. And if the order changes, it doesn't matter. Okay, if the negative number comes first or the negative number comes second, it doesn't matter. Okay, if you have one negative number and one positive number, subtract the two numbers. 4 minus 2 is 2. And then whichever one of these numbers is bigger, that's the sign that wins. Okay? Since 4 is bigger than 2, this is negative 2. All right? So if you, just for kicks and giggles, do the same thing. 6 minus 3, because these two have different signs. And now it stays positive because the bigger number, 6, is a positive number, okay? Be careful with those, all right? I sometimes go into the number line, but All right, so when you have to subtract numbers and there are negative numbers floating around, please apply the same rules as this, okay? This is negative 3 plus negative 6. When the signs are the same in your numbers, add the numbers. 3 and 6 is 9. And then whatever the sign of the numbers is, make sure that sticks around, right? And again, this should make sense, right? If you owe somebody $3 and you owe somebody else $6, how much do you owe? 9, right? It's the same concept, okay? All right. Yeah, please do. Go ahead. If you have to subtract negative numbers, this is where it gets a little bit on the tricky side. The key here is that you want to change this still to a plus. And now the whole point here is that two negatives, what do two negatives do? They become positive, right? And now you can treat it just like it's good old 4 plus 6, okay? So just be careful. What I like to tell students is that there's no such thing as subtraction even. It's all addition, where what you do is when you change this negative to subtraction to addition, just change the sign of your number. Here we change the sign of our number from being 6 to negative 6. Here it was already negative 6. We changed the sign from negative 6 back to positive 6. Negative signs are kind of like a toggle switch, right? You either turn it on or you turn it off. And every time you have to switch, it just switches back and forth, okay? All right, so you have to be able to multiply with negative numbers. The rule for negative numbers, folks, if there's an odd number of negative signs, your result is negative. If you have an even number of negative sides, your result is positive. So since 1 is an odd number, negative 6 times 4 is negative 24. If you have two negative numbers, 2 is an even number, this switches you back to positive. All right? And you could get something weird, negative 2 times negative 1 times negative 2 times negative 3. Again, when you're dealing with these sorts of things, multiply all the numbers. 2 times 1 is 2, times 2 is 4, times 3 is 12. And then just determine, is it positive or negative? Count the minus signs. 1, 2, 3, 4. 4 is even. This winds up positive, okay? All right, so division works the same as multiplication. When you're dealing with negative numbers, if you have one negative sign, it's negative. If you have two negative signs, your result's positive, okay? Again, same rules. All right, now, what happens when we start putting them together? Order of operations. What's the phrase you use to remember them? Whichever one you use, PEMDAS, or please excuse my dear Aunt Sally. What's the P stand for? Parentheses. What's the E stand for? Exponents. Realize that in this class we will not deal with exponents too frequently, just so that you know. M and D. Multiplication and division. A and S. Addition and subtraction. Please realize that there are 4 orders. There's not 6. Multiplication and division are at the same order. Within the same order, left to right. In other words, here it's pretty straightforward. What are we going to do first? Multiply. We're going to do 2 times 3 first, then add. If we get more complicated equations, suppose I give you 10 minus 12 divided by 2 times 3 plus 4. So we're looking at this expression and we're saying, okay, what do we got to do first? We got to do the multiplication and division first. The M technically shows up first in this phrase, PEMDAS. Multiplication and division are the same level. So when you have these multiplications and divisions occurring all at the same time, you have to go left to right. Do not do the 2 times 3 first because multiplication is easier. That's wrong. In your brain, that's what you're going to do because you guys can multiply in your heads easily. So you're going to say 2 times 3 is 6. But look, okay? See the division sign and say division and multiplication are the same. Therefore, I have to do the division first, then the multiplication. This is actually 10 minus 6 times 3 plus 4. And then do the multiplication, right? So left to right within this group. All right? So then it's 10 minus 18 plus 4. Again, the same with addition and subtraction. You guys know how to add better than you know how to subtract. Don't do 18 plus 4 first. That's going to wind up giving you a wrong answer, okay? Do 10 minus 18. And especially when you look at 10 minus 18, you're thinking, oh, crap, that's one of those bad ones, right? It is, but you have to do that first. 10 minus 18 is negative 8. And then last but not least, negative 8 plus 4 leaves you with negative 4. Okay, that's just you being careful. You know these things. You've been throwing them at you. The nice thing about it is that your calculator knows all this crap too, folks. If you punch this phrase into your calculator, it's going to spit out negative 4 at the end. All right? And that's the one thing that makes me want you guys to memorize this stuff is because technology has gotten to the point where it does it for you, but if you don't know how to punch it in so that it does the right thing, you may screw it up. Right? If what you really meant to do was do 3 plus 4 first, and you don't put those parentheses in on the calculator, guess what? It's not going to use them, okay? So just be careful and remember your order of operations, all right? It's not that I think that you have to do it on a regular basis, but you are going to have to input these things into technological devices, and those technology devices do know it. And so if you screw it up, your answer may wind up wrong, okay? So please be careful with that. All right, so we okay with this? Okay, whole numbers and dealing with integers. In theory, again, folks, this, to me, should have been a review for you, right? Now, Chapter 2, which is what we're going to work on today, get through hopefully in an hour and a half, are fractions. Jill. All right, so first off, what is a fraction? It's division, right? Technically, now you guys know, I never really have to worry about them. Unfortunately, though, we will have to because lots of times you're going to see fractions out there in the real world, okay? So, a fraction is just a rational number. And a rational number is any integer divided by any other integer, okay? Any integer over any other integer. With one exception. What's the exception to this rule? Oh, no, improper is okay, actually. Positives and negatives are okay. What down here is bad? No, negatives down there are actually okay. But there is one number that's bad down in the denominator. 0, yes, right? If you get out your calculator right now and you punch in 4 divided by 0, what's it going to do at you? 0. Yeah, it's going to barf at you, right? And that's not a bad thing, right? Again, the calculator knows that this number cannot be 0, okay? If you try and divide by 0, the calculator's going to barf at you. Don't freak, just say, okay, that's a fraction that's not real, okay? There's nothing wrong with that. All right, so there are 3 types of fractions: proper, improper, and mixed. Proper fractions the numerator is less, strictly less than the denominator, okay? I suppose I should be careful here. A fraction has a numerator and a denominator. Numerator always on the top, denominator always on the bottom. I'm an Indiana guy, so the way I remember this, folks, is Notre Dame. ND. That's how they always write it, so that's how I was taught it back in 2nd or 3rd grade whenever they did this. So that's how I keep track of it. Please realize the top of a fraction is the numerator, the bottom is the denominator. And again, as long as this number is less than that number, it's a proper fraction, right? So doesn't matter. And if the fraction has negatives floating around in it, nothing wrong with that. That's a proper fraction. It's no big deal. In fact, technically that's a proper fraction, okay. Having a 0 in the numerator, there's nothing wrong with it, right? If you have 0 in the numerator, what's your number? 0. Doesn't matter what the denominator is, always 0. Okay, 0 on the top, okay. 0 on the bottom, not so good. All right? Four-eighths, perfectly good, proper fraction. Of course, what are all of you screaming to do when you see the fraction 4/8? Reduce. We'll get to that. But it's perfectly okay to write it as a proper fraction. It's just not a simplified proper fraction. An improper fraction is the exact opposite of proper. That means that the numerator is greater than or equal to the denominator. So 13/5 is a very good improper fraction. Again, it can be negative. That just means the number is negative. There's nothing wrong with negative fractions, folks. All right? It could be the exact same numerator and denominator. What happens when you have the exact same numerator and denominator? It's 1, right? But writing 1 like this, there's nothing wrong with it. It's just an improper fraction. All right? Let's see. You can get really carried away if you want to. As long as the numerator is greater than or equal to the denominator. A mixed fraction, that's where you have whole numbers and fractions, okay? And again, it's perfectly okay if that number is negative. The negative, though, is placed in front of the whole number. That's standard practice, okay? Please note that when you write a mixed fraction, the fractional portion must be proper. This mixed fraction is actually not correct, okay? Anytime your fraction is improper, you have to fix it so that it becomes proper, and we'll talk about that in a little bit, all right? So, definitions. The reason why you need to know these things is on the test, I am going to tell you what form I want the answers in, and you have to follow directions, okay? One of the hardest things to get you guys to do is to read directions. So the first test has lots of directions on it so that you get in the habit, all right? And the reason why I say this is that there was actually a business in town that was doing interviews, and the interviews had a set of directions that an applicant had to follow to start the interview. And if the person didn't exactly follow the instructions before the interview started, they excused them as soon as they were done. Right? So the instructions in the interview said, enter the room, leave the door open, and sit in the middle seat of a set of 3 seats set next to each other. If they didn't follow those rules exactly in order to start the interview, they just kicked them out and went to the next one. So if they closed the door, they were out. If they sat in the first because it said the middle one. Follow directions. That's all I'm going to say for now. All right. So when we deal with improper and mixed fractions, Please note that there is a 1-to-1 and onto correspondence between improper and mixed fractions, meaning that you can rewrite any improper fraction as a mixed fraction, and then back and forth. All right? And you need to be able to go back and forth between these two formats. So, improper to mixed. Take this mixed fraction, convert it into or take this improper fraction and convert it into a mixed fraction. Method, long division. You guys know how to do some long division in your head, hopefully. Take the denominator, divide it into the numerator. How many times does 5 go into 13? 2. 5 times 2 is 10. 13 minus 10 is 3. Once you've used up all of your numbers, what is the 3? It's the remainder, which becomes the numerator, right? So this, the remainder, becomes the numerator. Numerator, if I could spell the word. You guys spell it correctly. I will misspell things all over the place. I'm a mathematician. I can't write. So this number is the whole number. This is the numerator. Please note that your denominator never changes, okay? It'll always stay the same. So if I ask you to convert 1,422 over 11 into a mixed fraction, you do the same thing, okay? It's good old long division, all right? And the sad thing about it is that if you punch this into your calculator, what's your calculator going to do? It's going to give you some decimal, right? You need to know how to do long division, because converting this into action, So a little bit of review on long division. 11 goes into 14 how many times? 1. Once you get a remainder coming down here, keep using numbers until you have used them all. How many times does 11 go into 32? Twice. 2 times 11 gives you 22. Again, keep subtracting. Got to keep using numbers. How many times does 11 go into 102? 9. Once you have no more numbers, this is your remainder. Hence, that's going to become your numerator. So your mixed fraction is 129. Whatever is up here is your whole number. The remainder becomes your numerator. Don't ever change the denominator. Okay? I know long division is archaic, and in a lot of school systems they've kind of said that you don't have to learn it anymore. To that. You need to know it. This is why, because you need to be able to go back and forth between improper and proper fractions, okay? So if it's been a while since you've done long division, do some practice. It's good, all right? You use this on a few other types of things, and it's not a bad thing to learn. All right, so does anything change if I make my number negative? Negative, say, 15/7. If it's negative, what do I do? Same thing. Just make sure you don't lose the negative sign, okay? So you're still going to divide 7 into 15, and just completely ignore that negative sign until the very end, and then make sure you bring it back, right? So how many times does 7 go into 15? Twice. Notice I put my negative sign in front of my whole number. What's the remainder? 1. So just don't get freaked by the minus sign, and at the same time, don't lose it. Okay, it's still there. Now, how do we go the other direction? From mixed to improper. If If you divide one thing, the opposite of division, multiplication, please note that you multiply whole number times denominator plus numerator. So whole times denominator plus numerator, if I could spell the darn word still, and then remember that the denominator never changes. So to convert this to an improper fraction, whole number times the denominator plus the numerator, (21/5). If it's negative, just be careful. Treat the negative number at the very end. Okay. The reason that I go over a negative number on this is that I had a student one year when I didn't explain this who said, "Oh, okay, great. Take the whole number." This is the wrong way, so don't write this down. Okay. Right, according to my formula that I wrote up here, right, I should take the whole number, which is 3, but there's a minus sign, so bring it along. See what's going to go wrong? What's negative 3 times 3? Negative 9. When you add a 2 to a negative 9, what happens? Yeah, it's negative 7. But that's not the correct answer, right? What should really happen is that we should take 3 times 3 and get 9, and add a positive 2 to a positive 9 and get 11, and have it be 11 over 3, and have this, and then have it be negative. I didn't point this out to students. Technically, that's the way the negative sign works. You do everything inside the parentheses and then attach the negative sign at the end. So that's why I say ignore the negative sign, but don't lose it. Okay? So this should be negative 11/3. All right? So just be a little careful. Sometimes I give formulas and students are like, well, it's math. I have to do exactly what he said instead of what he meant. So now I'm pointing out to you just to be safe. All right. We will see in a little bit why this is important, because when you add, subtract, multiply, and divide fractions, this is often what you have to do. All right? So any questions on going back and forth between improper and mixed? We're good? Okay. The first sentence on the test, that first test that you take, will be all fractions must be reduced to simplest form, period. Okay? Anytime you write down a fraction in this class, simplify it. Okay? So when I give you this fraction, 2/4, you know that it's 1/2. Why? Because it's true, and I agree, but why? And 2 can go into 2. So, but if we're taking away a 2, aren't we changing the number? Why aren't we changing the number? Okay, but that means I've taken a 2 out of both of those. Haven't I changed the number? I mean, I've taken something away. Why doesn't it change it, right? What's 2 over 2? 1. When you multiply or divide by 1, what happens? Stays the same. So what we're really doing when we're reducing fractions is what we're doing is multiply or dividing by 1. We're basically saying divide the top and the bottom both by 2, because 2 over 2 is 1, and when we divide by 1, we don't change the number. That's why reducing fractions actually works. You have to know that 1 is an identity for multiplication and division. When you multiply or divide by 1, nothing changes, okay? And it can work the opposite direction, right? I can tell you that 1/2 equals what over 8? 4. Why did you know that? Because in order to get from 2 to 8, what do you got to do? Multiply by 4. So if you multiply by 4 in the bottom of the fraction, what are you going to do on the top? Same thing, okay? And why do you need to potentially do this? To find common denominators. We're not at adding yet, but we'll be there real quickly. So, is this fraction simplified? Why not? How do you know? Right, but how do you know that this is not? What's your first instinct to look at these two and say, I know I can simplify it? 4 and 8, they're even. What happens when numbers are even? You can get a 2 in them. So one of the things that you do in your brain, again, you don't know you're doing this, but you do, is you apply rules of divisibility. Great word to use, by the way, divisibility. Anytime you use a word that has more than 5 syllables, you look smart. You do. Divisibility. And the other cool thing about this is that it's all I's. I like that stuff. All right, so for numbers to be divisible by 2, they just have to be even. So we know that we can simplify this. All right, so dividing by 2 really quickly, we'll say 2, 1, 2 over 4, 4, 4. What do you do next? Do it again. Don't stop. All right? Just because there's 1, 2 doesn't mean there might not be more than 1. Keep going until you get numbers that are not even in the top and the bottom, okay? So just keep going. 2 goes into this, and if you have to do it the long way, don't sweat it. I divide by 2 quickly because I do it a lot. Am I done yet? Keep going. Okay. Once you're doing 2's, do as many 2's as you can when you're simplifying your fractions. 2's are the easiest thing to deal with. Start with 2. Guess what the next easiest number is after 2? You guys are smart. Okay, here's a trick question. When is a number divisible by 3? If it ends in 3. So 13 is divisible by 3? Crap. Good try. Okay, you're on the right track. You're on the right track. Oh, no. Sum of the digits is divisible by 3. So you add up all of the numbers in the number, and then if that sum is divisible by 3, so is your number. So you guys know that 12 is divisible by 3, right? Now you have another rule for why it is. What's 1 plus 2? 3. 3 is divisible by 3. 48. 4 and 8 is 12. You now know that 48 is divisible by 3. Hopefully you guys probably remember 3 times 16 is 48. But now you can do really big numbers. Is that divisible by 3? 7, 11, 13. Is 13 divisible by 3? No. Okay? So, this fraction right here, can I take 3's out of it? Well, I can for the 111, right? Because 1 plus 1 plus 1 is 3. So I should be able to do it, right? Why not? They both have to work. Yes, good. 5 plus 3, 8. Perfect. This is as simplified fraction as it can go. All right? All right, so that's a nice rule for 3. And again, when you are doing simplifications by 3's, do it once. Please don't stop. It's the same as 2's. If you do it once, you may have to do it again. Keep going, right? So after you do a simplification by 3, keep going on the off chance that you have to go further, right? So 117 over 999. Simplify this fraction. First, technically, check if it's even, okay? Don't skip 2. Check it. These aren't, obviously, you're safe. Okay, so you go to 3s. 1 plus 1 plus 7, 9. It's in there. 9 plus 9 plus 9, 27. Yep, there's a 3 in both of these. Divide both of them by 3. So divided by 3, divided by 3. I'll do these for you. 39 and 333. Am I done? No. Why? Because 3 plus 9, 12. 3 plus 3 plus 3, 9. Do it one more time. Okay, so the same as 2's. Repeat as much as you need to. Okay? All right, can I go one more here? Unfortunately, no, because 13. Okay, we're done. All right, so what comes after 3? 5. We're going to do 4 only because I want to show it to you. Technically, you don't have to do 4 because 4 is really just 2 times 2. So when you do your second 2, you basically got to 4. Right? But I want to give you the rule just so that you know. If the last 2 digits are divisible by 4, the entire number is divisible by 4. In other words, this number, 2,824, is divisible by 4 because you look at the last 2 digits. And is 24 divisible by 4? Yes. So when you take one 2 out, guess what? You'll be able to take another one out. Don't worry too much about it, about this rule, because 4 is just 2 2's. All right? So technically, yes, the next valid one that we work with is 5. What are the rules for 5? Numbers that end in 5 or 0 are divisible by 5. Again, just keep that one in mind. These are the 3 that I want you to know and to use on the test. Okay? Be able to deal with 2's, 3's, and 5's. We're going to do 6. You don't have to know it because it's really simple. 6 is the product of what 2 numbers? 3 and 2, right? So in order to be divisible by 6, it's just got to be even, and then also have its numbers divisible by 3 if you add them up, okay? Because 2 times 3 is 6, all right? 7, there's a rule for 7. I'm not even going to talk about it because it's just weird. There is one. If you want to look it up, you can. It's just weird. Deals with subtracting 7 from the numbers and whatever. Don't sweat it. All right, so 8. The reason I want to show you 8 is because 8's a special number. 2 times 2 is 4. 8. 2 times 2 times 2, right? It's 3 2's multiplied together. So the rules for divisibility when it comes by 2 is that the last digit is divisible by 2. That's what even means, right? Last digit divisible by 2. Notice what happens when you have 2 2's. What do you look at? You look at the last 2 digits. If you have 3 2's, guess what? You're going to use 3 digits. Again, this is not a rule I want you to know or memorize necessarily, but it's something that I want to point out to you, right? This is what's known as a pattern. Math is loaded with patterns, folks. It's all over the place. And the thing about it that I want to point out to you is that when you get into business, businesses often follow patterns as well. And part of your job when you start running your own business, because eventually you will, is to look for patterns and adjust to them, okay? This is pointing out to you that patterns exist so that you can see them, because the math is going to show you, the numbers are going to show you. That's a lot of the reasons why businesses keep numbers for so long, right? In the end, businesses just want to show a profit, right? So after 1 month, if the number's away, right? No, they keep them around. The reason they keep them around? To find patterns. And patterns are what make businesses more flexible in order to survive, right? So if a business notices, suppose you decide to open up a restaurant, and you're in Wisconsin, so what do you do on Friday? Fish fry, right? I mean, that's what every restaurant does in Wisconsin. If every Friday you find out that by 8 o'clock you run out of fish,
You're done.
what are you going to do after you've run out of fish a few Fridays in a row? You're going to order more, right? On top of it, what might you do with your fish fry, price-wise? You will raise the price a little bit, right? These are the sorts of patterns you want to look for, things where something is happening regularly in a regular basis. So if on Mondays you always run out of, meatloaf, again, keep track of the numbers, look for patterns. The math shows it to you, look for it, all right? All right, so anyways, these 3, please make sure you're able to do. And again, remember that for the first test, half the test is calculator free. So you need to be able to do this old school. All right? All right, so reducing fractions, be able to. All right, now. We know our rules. Now we have to start doing things with our fractions. You do have to add fractions. True or false? What? Did I not add right? 1 plus 2 is 3, and 2 plus 3 is 5. Oh, yeah, that's right. Darn it. False. Common denominator. When you are adding fractions, folks, the denominator must be the same. You probably, if you're young enough, can remember that back when you learned how to add fractions, they always screamed about how you had to find the least common denominator. You don't. There's no reason to find the least common denominator. It helps, it makes life easier, but it's not absolutely necessary, okay? Just find a common denominator. That's good enough. Because once you get a common denominator and add them, if you didn't find the least one, what happens? You can simplify the fraction after you add them, okay? The reason why your teacher screamed and yelled at you about finding the least common denominator is so that you wouldn't have to do that simplification at the end. There's nothing wrong with it. Go ahead and do it when you need to, okay? So when I add 1/2 and 2/3, how do I do it? Six is the common denominator, and that's actually the least common denominator, right, in this particular case. So how do I get this guy to have a denominator of 6? Multiply by 3. If I multiply the bottom by 3, if you need to, write this when you do it, just so that you keep it straight in your head. It's not a bad idea. What do I have to multiply here to get 6? 2. And then add across, and we're all good to go, right? Right? What? I added the top and I added the bottom. Oh, yeah, those bloody rules. Yes, the denominator, the whole point of getting the common denominator is so that you can just add the numerators, keep the denominator the same. Again, at this stage, check the directions for the problem. If the problem says the answer must be as a mixed fraction, you need to convert it. If the problem says answer it as an improper fraction, you're done. okay? I know that you want to write this as 1 1/6, but read the directions and make sure you answer the question according to the directions, okay? If you want to, you can say this is 1 1/6. But on a test, if I say the answer should be as an improper fraction, you give me both of these, it's perfectly okay, but if you screwed this one up, suppose you accidentally changed this to 1 2/7 or something because you made a mistake, or you just brain farted, whatever. Your answer is correct here, but you then wrote down something that was wrong. Guess what I have to do? I have to take points away, okay? So I know that you guys don't like improper fractions. It's okay, but if I'm asking for them, make sure you give them to me, and honestly, I would rather you didn't give me the mixed fraction with it, because all you're doing is setting yourself up to miss points. It's okay. I'm not going to be mad if you do it correctly. I'm never mad if you give me more correct information. I'm just sad if you give me more information and it's not correct. Okay? So, if there are negative numbers floating around in here, let's keep it easier. Suppose I asked you to add -1/2 plus 5/2. I actually already have a common denominator. Make it easier. Just don't lose the minus sign, right? This is the same as that. Apply your rules for adding negative whole numbers that we just did a little bit ago, okay? So this is going to be 4/2, and what are you going to do with that fraction? Depends on what the directions say, but at a minimum, you are going to reduce it, right? If this says leave it as an improper fraction, you do have to reduce the fraction always. It is just 2, but make sure you always reduce these things. All right, so if we add fractions, what do we do next? Subtract them. Remember that addition and subtraction are really just the same thing. This is really the same as 3/4 plus -2/5. Those are exactly the same thing, right? The same thing you did with whole numbers applies to fractions. They're not special. Fractions are just like a number. What do you do to add fractions? Get a common denominator. All the same rules apply. Again, I like to write what I multiply by over my fraction so that I don't screw it up and multiply by the wrong numbers. 5 times 3 is 15/20. 4 times a -2 is -8/20. And now I can do 15 plus -8, or 15 minus 8, which is just 7/20. Get your common denominator. Don't lose your minus signs. All right, now, what happens if your numbers are mixed? You can, when you are adding fractions, it's easy to go ahead and just add the whole numbers and then add the fractions. That's perfectly okay. Okay? There's nothing wrong with it. You can say that this is the same as 4 plus 3 plus 1/2 plus 1/4. That's okay. Adding the fractions, it's okay. All right? 4 and 3 is 7. Get your common denominator. 2/4 plus 1/4. 7 and 3/4. And then again, read the directions for how the answer should be written, right? If mixed fraction is how you should answer it, you're done. If I ask you to give it to me improper, convert. Okay, again, read directions. Now, you may run into problems when you are subtracting fractions where it becomes problematic. This, again, you're dealing with fractions. When you're working with it, this, you want to get a common denominator, 2/4. And you can, if you want, subtract the whole numbers and then subtract the fractions. The problem with it is that when you do 4 minus 2, what do you get? That's 2. But when you do this, what do you get? You get a negative. So is my answer 2 and negative 1/4? Nope. That's actually not correct. When you answer problems with a mixed fraction, this fractional portion has to be positive. The key to this is thinking that this is really just 2 minus 1/4, or 2 plus a negative 1/4. So you actually have to subtract 1/4 from 2 in order to get the right answer. A better way, what I consider to be a better way to do this problem is, instead of subtracting the whole number and subtracting the fraction, convert everything to an improper fraction instead. If you convert your mixed fractions into improper, you will never run into this problem of your whole number being one sign and your fraction being the opposite, right? 4 times 4 is 16, plus 1 is 17. 2 times 4 is 8, plus 2 is 10. When I make them improper, I've got a good, nice 17 minus 10, and I'm all good to go, right? This is 7/4, and if you want to convert it into a mixed fraction, 1 3/4. Because what is 2 minus 1/4? 1 3/4, okay? This was one of the questions from the practice test that I gave you on Monday, dealing with this kind of a problem, all right? My advice to you when you're dealing with relatively small numbers, make them improper. You'll never run into this problem, okay? The other reason that I tell you to do this will be evident in a little bit. Because after you do an addition and subtraction, what do you do next? Multiply. True or false? Is it true or false? False? Who said it was true? Alex, why is it true? Because it is. When you multiply fractions, folks, you just multiply the numerators and multiply the denominators. Which is why when you do the addition and subtraction piece, people often get confused because they're like, wait a second, I couldn't just add the numbers across. But when you do multiplication, you do get to do that. Sorry. It would be nice if math was consistent, but it's not always consistent. When you multiply, you just multiply across. This is true. All right? The only thing you have to be a little bit cautious of, multiply them across. There's nothing wrong with it. 1 times 4 is 4. 2 times 7 is 14. After you get the result, what are you going to do? Simplify. All right? Multiplying fractions is easy, folks. So you just had to get the brain rejarred. That's okay. That's why I go through this really quickly, is to make sure that you get this back into your system. When you're adding or subtracting, get that common denominator. When you're multiplying, be happy, right? All right, so when you multiply mixed fractions, The rule is that you do exactly the same thing. The problem is that in order to multiply the numbers, you have to convert these to improper fractions. Okay? There's no trick to saying multiply the whole numbers and multiply the fractions. That doesn't work. All right? You have to convert these things into fractions, multiply across, and then apply all of the rules that you need. So you have to take this and say, this is 5/2, and multiply this by 16/5. You must convert your mixed fractions to improper. Okay? And now you can just apply the rules that you did up here. Multiply the top, multiply the bottom, and then simplify. What's 80 divided by 10? 8. All right? Yeah. Mm-hmm. You could, if you wanted to, you could start reducing. Say take out a 10 from both of them, if there's a 10 in both, right? Or if you wanted to, you could do 2s, right? You could say this is 40 over 5, and then you can reduce these by 5s. This is 8 over 1. 8 over 1, go with 8. However you want to get to 8, it's cool. Take away the zeros, just get to 8. I agree. When you have two numbers that have zeros at the end, you can just lop off as many zeros as there are, because basically you're dividing the top and the bottom by 10. All right? All right, so if you can multiply, yes. You can divide fractions. There was one of these on the pretest too. What I tell people is that you never divide fractions, you just flip and multiply. All right? Whatever follows the division sign, you convert it to its reciprocal and change your division to multiplication. All right? When you convert this to a multiply, this gets reciprocated. And then you just follow the rules of multiplication.
Can't you just cross multiply?
Yeah. I mean, because if you do...
If you just, once you reciprocate, you just cross multiply and you get an 82/3. You don't have to go through all the work, right?
No, it's fine, yeah. It works the same way. I mean, there's no difference between that and flipping and then multiplying across. But yes, cross-multiplying when you're dividing fractions is the same thing. Just be a little cautious. 4 1/4 divided by 1 1/3. If you have to divide mixed fractions, convert them to improper first. Just like you had to do with multiplication, you have to do the same thing with division. 4 times 4 is 16, plus 1, 17 over 4, divided by 4 over 3. And then again, remember that you don't divide fractions, you just flip and multiply, or cross-multiply if that's what you want to think of it as. Please remember that what you flip is what follows the division sign. Technically, don't flip the wrong one. That tends to be the problem students run into, is flipping the wrong fraction. All right? But this, just multiply the two numbers, you're all good to go. Again, read the directions as to what's the right way to answer it, though. All right, so that's multiply. Not bad? Okay. Again, I would like to think that you have all done this at least once before. It may have been a long time ago. So partly what I was trying to do was to just jog your memory, get yourself back on track so that you remember how to do it. All right, so I have 4 sticks that are this long. 1/3 of an inch, 1 1/5 of an inch, 1 1/10 of an inch, and 2 inches. Or feet, whichever one that is. Guess what I'm going to do with these sticks? I'm going to line them up, and I want to know how long it is, right? If I put my sticks together, how far do they reach? Again, remember, folks, that the key to this particular class is word problems, word problems, word problems. So yes, you are going to add, subtract, multiply, and divide fractions, but what I'm going to do is phrase them in word problems. So the bigger challenge with this is doing the translation. In this instance, hopefully it's relatively straightforward. What do I do with all of my numbers? Add them, because you're putting them together, okay? When you are dealing with word problems, folks, please realize that pictures are often a good idea, okay? I recommend pictures. Here's 1/3 of an inch. Here's 1 1/5 inches. Here's 1 1/10 inches. Here's 2 inches. It never hurts to draw a picture. I mean, you can look at it and say, oh yeah, no problem. I know what I have to do with all of these numbers, so I'm just going to do it. 1/3 plus 1 1/5 plus 1 1/10 plus 2. How are you going to add those? Find a common denominator. What is a common denominator? 15 for these two, but we got a 10 in there. Yeah, 30. Okay, so to get this over 30, what are we going to do? Multiply by 10. What do I got to multiply 5 by to get to 30? 6. Again, this is why I write it down. So that you make sure you multiply the top and bottom of each fraction by the right number. This one's 3 and 3, so this is 1 3/30 plus 2. Now that you have a common denominator, and it's adding, add the whole numbers, add the fractions. 1 plus 1 plus 2, 4. Don't lose the 2. Again, that when there's no fraction part to your number, a lot of students will all of a sudden, that'll just disappear. Don't let that happen to you, okay? Add your fraction components, 10 plus 6 plus 3. If you gave me this as the answer, I would have to take 2 to 3 points off on a 10-point question. Why? Can't be simplified. Suppose I said the answer should be a mixed fraction, so this is perfectly okay. What's missing on the number? The units. Okay, word problems often have units. Make sure you give me the same units in my answer, okay? If someone asks you to add a bunch of numbers and they're all feet and they give you a number coming back, someone may think that that number is in inches. And then you would build the Hubble telescope. Right? When the Hubble telescope was built, one of the problems with it was that it was designed in Europe, so it was all done in the metric system. When it was built in the US, guess what we used? We used the English. We used inches and feet and all that other business, and somebody didn't convert one of the numbers because probably someone didn't mark down that it was 4 and 3/5 of a centimeter. They just said it was 4 and 3/5. Yes? Oh. Thanks, Ron. That's all right. You're welcome, or thank you, whichever way it goes. All right, so again, when you're dealing with word problems, very much so is important to give me units. Usually, folks, when we're dealing with business, what are the units? Money. So give me dollar signs, okay? But there are times where we'll be doing construction work or what have you. So we may have something like I have a desk with a hutch on it. If the hutch is 2.5 feet tall and the total height of the desk and hutch is 4.25 feet tall, guess what I'm going to ask? How tall is the desk? Again, if you can see what needs to be done, it's no big deal. My advice, though, draw a picture to be sure. You don't have to, but it's never a bad idea. I have a desk with a hutch. If you want your drawings to be nicer, you can make it nicer, right? So maybe the hutch is really a shelf, and you've got books on your shelf, you know, and maybe you want to put in what your books are, right? So maybe you like, maybe you have a Bible with you wherever you go, so you put a Bible on your desk, right? Decorate as you see fit, right? I mean, maybe this desk has a drawer over here. Math can be a little on the dry side, folks. Pictures make it a little less dry. Go ahead and draw them, right? And then put in the information that I gave you, all right? The hutch is 2.5 feet tall. Oh, cool. This, 2.5 feet. The total height of the desk and hutch is 4.25 feet. What am I looking for? That's what I'm looking for. What do I need to do? Subtract, because the sum of the desk and the hutch gives you the total. So in order to find what's left, subtract these two. I need to take 4.25 and subtract 2.5. Again, if you can see it right off the bat without thinking about it, cool. But I like the pictures that shows that you're problem solving. Okay, one of the things that, again, that businesses are complaining about is that students are coming out of school without the ability to solve problems. They can do this, but they can't read this problem and translate it into the math. Hence, that's what we will focus on a lot in this particular class. If we are subtracting mixed fractions, what are we going to do? Common denominator. So first we say 4 1/4 minus 2 2/4. My advice when you're subtracting these sorts of things, convert them to improper. Tends to make life easier. Times 4 is 16 plus 1. 2 times 4 is 8 plus 2. This is 7/4. I probably would ask you to answer this question as a mixed fraction. So you would say this is 1 3/4, and you would make sure feet. All right? Again, we already did 4 1/4 minus 2 1/2, so hopefully the answer didn't change. Word problems with addition and subtraction. Let's see. I paid, let's keep it easy. I paid $140,000 for my house. My brother's house is 4/5 of 4/5 of the price of my house. What am I going to ask? What did my brother's house cost, right? So I paid $140,000 for my house. My brother's house is 4/5 of the price of my house. Here's where it gets a little bit tricky. Of. How does of translate into math? Times. It's multiplication, okay? To find my brother's house, it is 4/5 of my house. Therefore, my brother's house is 4/5 times my house. Note that the of translates to multiplication. All right? How would you multiply those two numbers? How do we multiply any fractions? What do we have to? This is a mixed fraction, right? Put it over 1. Please remember, folks, that any whole number is just itself over 1, right? Because when you divide by 1, nothing changes, right? So this is really 4/5 times 140,000 over 1. Multiply the top, multiply the bottom, simplify. And again, that fraction can be simplified because it ends in a 0, it ends in a 5, or 5 can divide into 560,000 evenly. My brother paid $112,000 for his house. He lives in Indiana, though, so houses are cheaper there. All right, now, you have to be a little bit careful when you start getting those ofs in there because you can get twists on the phrasing. Let's see. I paid $120 for a shirt. So get the numbers a little bit lower. Not quite as painful. But, I mean, that's a very common type thing over there. But my brother is buying the same shirt. My brother paid, let's go with 2/5 less than the price for his shirt. How much did my brother pay? For his shirt. So, is there an of in this sentence? Is the of implied, though? Yes. 2/5 of my shirt. English is a really nasty language. We make a lot of assumptions about it, and then we tend to be lazy and not write them down. Okay? You knew what I meant when I wrote this sentence, but technically that of is in there. It's 2/5 less than the price of my shirt for his shirt. But if you said that, it would sound weird, right? Because we imply the of in there without actually writing it. That's why sometimes translating to math is a pain in the ass. because English sucks. If we were in Germany and you'd be doing this in German, that of the price would be in there, because in Germany you say everything that you mean and you do it in very... But, you know, the Germans lost the war, so we get to be Americans. So, how do I deal with this problem? What does the word less make you think? Subtraction. So, the of is multiplication, and then after the multiplication, you do the subtraction. All right? So, in this particular case, you're going to take 2/5 of the price and then subtract that from it. That's the difference between just multiplying and getting the answer versus multiplying and then either adding or subtracting, right? So if I said my brother paid 2/5 more than the price of my shirt, I would still take 2/5 of the price, but then I would add it as opposed to subtracting it. So these types of words I want you to look for and know what they mean, right? Less means subtract, more means add. Search for them, highlight them, underline them, circle them, do whatever it takes so that you don't screw it up, okay? So 2/5 times 120 is the number that we want to subtract from 120. It's just good old fractions, folks. 240 over 5. It ends in 0 and ends in 5. This has to divide evenly. 5 goes into 24. 4, 48. What am I going to do with that 48? Oh, what is that, 72? My brother paid $72 for his shirt. Okay? So, when you're dealing with sentences that have these clarifiers like more, less, added to, subtracted from, be careful, okay? All right, let's see. Make sure I'm not skipping anything on you. All right, let's do one more and then we'll call it a day. How's that? Let's see. I have 2.5 pounds of sugar. I use 1/4 of the sugar. Sugar starts with an S. How much sugar is left? When you're using sugar, what are you going to do? You're going to subtract. So, do I just take 2.5 and subtract 1/4? Why not? Yes, you see this magic word. Every time you see an of, when you're dealing with this class, folks, it should ring bells in your head. All right? You're using 1/4 of the sugar. So how much sugar are you actually using? I'm using 1/4 of the sugar. So I'm using 1/4 times the 2.5 pounds of sugar that I have. How do I multiply fraction times a mixed fraction? Get them to be improper, and then just multiply them across. 5 over 2. I'm using 5/8 of a pound of sugar. I'm making a cake. Apparently that's how much you need. What do you do with the 5/8? Subtract it from the 2.5. Left, 2 1/2 minus 5/8. When you're subtracting fractions, what do we need? Common denominator, okay? Keep that straight. You don't have to have a common denominator when you multiply or divide. When you subtract or add, you do. So this is 2 4/8 minus 5/8. Unfortunately, 4/8 minus 5, that nasty problem again. Make this improper. 2 times 8 is 16, plus 4 is 20. (20 minus 5). 15/8 of a pound is what you have left. Again, you should probably convert it into a mixed fraction. How many times does 8 go into 15? Once. The remainder is 7. There are 1 7/8 pounds left. Again, though, being careful once you see that 1/4 of, all right? Again, don't write this one down. I just want to point it out. How does this problem change if instead I say 1/4 of the sugar, I just say 1/4 of a pound of sugar? What is 1/4 of a pound of sugar? It's 1/4 of a pound of sugar, right? I mean, sometimes what it is what it is. If I gave you this problem, all you would have to do is take 2 1/2 and subtract 1/4. Because what you used was 1/4 of a pound. So the difference between 1/4 of a pound and 1/4 of whatever you started with is the difference between those two problems. All right? And that comes from reading carefully. Okay? It's more reading than it is math. Be ready, because that's the way most of the class is. Being careful. All right, you homework assignment, folks. Page 55 to 60, numbers 2 through 62, the evens. I also have all of this on Blackboard, a copy of the homework assignment as well, so if you have an older edition of the book, just print that off of Blackboard and you should be good to go. Please note, the challenge problems at the end of all of the homework, there will always be 2 additional challenge problems. The even one will always be worth extra credit. Okay? And again, please remember we have Monday off. That's MLK Day. Go to a rally, go to support some organization that recognizes Martin Luther King Day. And I will see you next week on Wednesday. Please note that the homework will be due on Wednesday. Okay? And we will start Wednesday by reviewing it before we move on into Chapter 3. All righty? Thank you, and have yourselves a good day. Oh, and turn me off, would you? Just click the same button.